Okay, we're rolling. Let's go to CMOS EDU, videos, written and video tutorials, and I'm going to make the tutorial 1 video file for tutorial 1, and I'm going to try to stick as close as possible. I printed this tutorial out, so I'll try to stick as close as possible to it as I can. I'm assuming that you have electric and LT Spice installed properly. Let's go ahead and open those two windows. So I'll verify that. Let's just go ahead and start electric real quick. And going through the tutorial, let's just verify with file preferences that we've got. Oh no, we don't. Okay, I guess I don't have this because let's go with 60. Wait a sec, what did the installation say? 128. So that means I likely don't have LT Spice installed, but we'll cross that bridge when we come to it. Okay, so let's go ahead and adjust the windows. Now those changes in the memory don't take effect until I restart electric, but that's okay. Let's maximize this screen, pull this down. The first thing the tutorial asks us to do is to change the color scheme so that we get white background colors, which, like I did prior to doing this video, I printed out the tutorial so I could just go through it as we move along. Okay, so down here is where we'll look for our messages. What we're going to do first is we're going to set electric up to use on semiconductor C5 process. And so I'll go, now I could hit the preferences right here, or I can go the long route and hit preferences this way. And the first thing it says is to go to technology, and then set this up for 3 layers of metal. And submicron rules, just copying, I got the tutorial printed out here. Second polysilicon layer, analog. And then the next one, it says in preferences, go to scale and set the scale to 300. That's our lambda. And then OK. And mark all libs. All right, so I think we're good to go. We're set up and ready to go. So let's go ahead and go to Explorer. The library name is no name. Let's go to File, Save Library As. It's in electric. I'm going to save it as tutorial 1 JLib. Save. Yes. All right. And so we've got a nice blank window here. This is where we draw our stuff. This is where we see our cells. These are where we see the components we use. And so first cell we're gonna make is cell, new cell. Again, I'm following the tutorial. R divider, and it's a view as a schematic. And we hit OK. And now when we see here in tutorial, we see the red indicates a schematic, and we have one cell in this library. Okay, so we go over to the components menu, and we want to put a node, which is a component. So we go to here, we select this node, and we go to NWell. So we want the NWell schematic resistor node into the drawing area as seen below. So I'll drop that down in there, and then go to Window, Fill. Okay, so all nodes have a highlight box. You can see as I put my cursor over that. What I want to do is change the property. So I'm going to select that node. Then I'll go up here to Edit, Properties. object properties, or just hit Control-I. And then it says we want the width to be 15, the length to be 187.5, and then the value of the resistor to be 10K, and it says hit more if it's not showing. So we'll put the resistor value as 10K. Okay. Then let's make another cell. Let's call this our divider as well. But we're going to make it a layout. And notice our component changes. So we have our Explorer here. And we see that yellow indicates, or orange, or whatever color that is, indicates layout. And then the red indicates the schematic view. And so these are what we use when we do a comparison between layout and schematic, those two views. So let's go put our layout here. Come down and drop. And again, you won't have this unless you selected the analog mode. We want an N-well resistor. Let's place that. Okay, we got to change its properties. So we go, it's highlighted, so we go to Edit, Properties, Object Properties, 15, 187.5, and resistance 10K. And then window, fill window. So at this point, we want to DRC, design rule check this to make sure there aren't any errors. So we go to Tools, DRC, check hierarchically. That's press F5. And we see down here there are no errors in this cell. Well, as in the tutorial, let's make an error. Let's select that, go to Edit, and I think this is the last time I'll do this. I'll just hit Control-I from now on to Edit Object Properties. And let's change the width. What does it say to change it to? 5. So we create an error. Okay, so we hit Window, Tool, DRC, check hierarchically. And it says there's 3 errors. So it says to see the errors, press the greater than or the less than sign. So we go Shift, greater than, and let's zoom in just like in the tutorial. And it says down here that y-axis minimum height. So it's not wide enough in this direction. And so we can hit Control-Z and go back. Let's do that a few times to our original size, and then go to Window, Fill Window, press F5 for design rule check, and it works. Okay, now we want to compare this resistor here, which is real simple, and let's do a check on it too. DRC check, no errors, with this resistor, and make sure that they're the same. And in layout talk, that's called a layout versus schematic to verify. But here in electric talk, this node here, where compared to the other one, or the layout to the schematic, we use a network consistency checking, which is the same as an LVS, and we go over here to schematic and layout views. And we're going to be doing this a lot to compare schematic and layouts to ensure they're the same. So we click on that, and it says that size is not checked. Okay, I don't have that in my tutorial, but let's, what I'm about to do in a tutorial, but let's fix this so it checks the sizes. Because if I go and make this, Control-I, make this a width of 35, let's say, and then I go Tools, ERC, NCC, Schematic and View, it says exports match, topologies match, but size is not checked. So let's go over to File, Preferences, go into Tools, NCC, and check sizes, or check transistor sizes. Okay. Then let's run that NCC again, and hit that. And it says, hey, one of them's got a size of 15 and the other's got a size of 35. So you might want to make a note of that when you're doing a comparison. So let's go ahead and do a Control-I on that node and change it back to 15. OK. And where was it centered? Control-I, 0, 0. OK. Now, as I mentioned, we're going to be doing an LVS, or NCC, also known as an NCC, between schematic and layout views often. And so instead of going Tools, NCC, Schematic and Layout Views, what I'm going to do is I'm going to go up and go to my Preferences, File Preferences, and go up here to General, and I'm going to bind a key so that I can press a key and it will automatically do the commands for me so I don't have to hit all the menus. That way I can go pretty fast. So I'm going to hit Tools, NCC, and then that's the schematic and layout views. I'm going to add and press the L button, and even though it's a lowercase, it's going to show up as uppercase. Hit add, and now normal, if there was a conflict, it would say you want to remove the conflicts, and we always do, because if we don't do that, then one key could correspond to 2 or more commands and we could get crazy behavior. So I hit add, so every time I press L, I'm going to get layout and schematic. And let's do a few others while we're at it. Check wells, we'll talk about that in a moment. Let's add that, and let's make that W for well checks. So L will be layout versus schematic, W will be a well check, and F5 is the DRC. Okay, we added that, and then let's go fill the window. Let's add one for that, and I'm just going to put that as F. Add. Okay, here we go. It says it also does make grid larger. Well, I don't want that. I'm going to remove all. And then zoom out or expand. I'm going to add and make that an X. Remove all. And then I'm going to zoom in, zoom box. I'm going to add and make that a Z. Add. Don't want to toggle zoom, so I'm going to remove all. Let me see any others that I'll be using quite a bit. Yeah, that's good for now. Okay, let's verify that. If I press X, I zoom out. If I press F, I fit. If I press Z, I zoom in, expand, fit. And then L does an NCC, and F5 does a DRC. Okay, so let's save everything. Let's go back now. Oh, let's do the well check now. Now, in digital design, we want all the N wells to be connected to VDD and all the P wells to be connected to ground. Well, here we're using N well as a resistor. So as we mentioned at the beginning, this is an analog design. So I'll go over here to Preferences. I'll go down to Tools, and then Well Check. And I see that I must have a contact in each area for both the P well and the N well. But for my N well must connect to power. If I hit Cancel and then do a well check, which is, and I'll do it with the menu item even though I set up a bind key, is check wells, I get 2 errors. And if I use the greater than sign, I see that, oh, this well's not connected to power. Well, let's go to Preferences again the long way and disconnect that so the well, which I'm using as a resistor, isn't connected to power. I hit OK. Then I hit well check, and there's no well errors. Okay. So now I can do a well check, no well errors. I can do a DRC, no DRC errors. I can do an LVS, which is also called NCC in electric, no errors. All right. So now I'm ready to draw a divider schematic. So I'll go back here to this node. I'm going to now Control and click will allow me to cycle through, but I'll just go over here and select it where I'm not on 2 things at once. And I'm going to hit Control C, or up here Control Copy. I'm going to hit X a couple of times, click out here, and then put Control V for copy. This one's active, so I'll go to Edit, Rotate, clockwise 90 degrees, Escape, move this over, Now here's something you have to get used to when connecting things up in electric. You have to select a port on the node with the left mouse button, and then you go out and use the right mouse button to draw an arc, which is a wire. And then down here connects the two together. Same thing over here, left mouse button, right mouse button, left mouse button, right mouse button. Now if I do a check, if I do a DRC or check the schematic, I'm going to get two errors. And the errors are, we can see, greater than, those two arcs or those two wires are floating. They're not connected anywhere. So let's go ahead and fix that. Or actually, let's do this. If I press Control, I can select that pin, and then I can make more pins here. And that's an error, because if I look, I've got all these unneeded pins. So when I do my DRC, it says, hey, you have 5 errors. Well, I don't want to go in and delete all those pins. So what I'm going to do is I'll go over and select Edit, Clean Up Cell, Clean Up Pins. Now I only have pins at the corners or at the ends. And again, I have to use Control to select through and get those pins. So I hit Delete now, hit F5 again. I still have my 2 dangling arcs. Let's go ahead and select that and then do a Control-I. Call that ground. Select that. Call that VN. Now when I do an F5, those arcs are no longer dangling. I'm going to go over here and I'm going to call this one VOut. So I've got all the, and I don't have to label the nodes. If I don't, electrical label them for me. Okay, so it's interesting to note what happens if I select an arc and I moves everything. And if I select a pin, use the Control button, and I move it, you can see, depending on which way I move it, the schematic changes accordingly. Okay, so and let's go and slide these up. Actually, I'm going to lower the grid there so I can get a little bit nicer looking schematic. And now I'm going to go add spice code because we're almost ready to simulate this thing. Whoops, I don't want that. I want miscellaneous spice code. I'm going to do a Control-I on that one, multi-line, and copy what's in the tutorial. VN 0 DC1 .tran 01. Okay, let's check it. No errors, no warnings. All right, we're ready to simulate with spice, but I don't have spice set up on here. So I need to go back. Here's what I have for LT Spice, which I got this at the beginning of the tutorial, clicking here and here. This is for the electric setup. This is for the LT Spice setup. So I need to go Spice 3, 3. Okay, let me go over here. Spice 3, 3. No header. Okay. No header. Those are all the same. Run ignore output, run program. And it says it's in C:. I got to verify that's where it's installed on this computer. So let's see. First, let's put it at run ignore output. Run ignore output. Then right click on Start, Explore. Let's go to Program Files, LTC, LT Spice 4, SCAD. Program Files, LTC, LT Spice 4. So let me verify. Program Files, LTC. Okay, so I can copy this. This is the right location. Do Control C. Go down and paste that in here. Go back over, and in the with arg fields, I want to paste this in. Control C. Control V. And then what? Override existing output. Okay, I know what that does, but if I want to save something, I don't want to click that. Run probe. raw LT colon. Override existing, run probe, raw LT colon. Okay, I think we're ready. So we go up to Tools, Spice, Write Spice Deck, and I have it to automatically run what I just set it up to do. And LT Spice runs, and then using the control, I select 2 traces, and I see that I have my blue as my input is 1 volt, and my green is my output, which is a 1/2 volt, and that makes sense. I'm going to go make sure that I don't automatically delete the raw files. So we'll go to Operation and Raw Files, and default is yes to automatically delete raw files, so you got to make sure this is at No in Control Panel Operation. Okay, so when I close this, I should get Electric pulling up its probe so I can do cross probing, and there it is. And I can pull this down and then go over to Explorer and double click. Vout. Oh, Vout's not showing up. How do I fit everything? Oh yeah, press F or window, fill window, right? Then I can zoom if I want over section, etc. And I can change the colors. Let's see, change the color. How about green, etc. Okay, anyway, so we've just simulated the schematic. Let's press F5 and make sure it's okay one more time. Now we're ready to go simulate or do the layout and simulate it. So let's try to make some mistakes, because mistakes are good to learn from. Let's query that, or Control I that, 0, 0, 15187. Then do a Control C, Control V. And then let's Control I that again, get its properties, X position 0. Looking good. And let's move it too close so we get an error. Hit F5. It says there's 2 errors. Press the greater than sign. It says less than 6 to node, so we can see those are the errors. Oh, and by the way, you can also see more detailed information about errors and all this stuff over here. Okay, so let's pull this bad dude down. Make sure it's still centered at 0. Oh, we're off a little bit. Press F5, see if the well resistors are far enough apart. Okay. Now let's go here. Okay, we click in here, nearest port's highlighted, then we right click down here. And we hit F5, no errors. Then we come over here, click, come up, hit F5, no errors. So let's go, and if we did an LVS right now, we would, NCC, we would get no errors, the layout and the schematic match. We got 2 resistors and 3 wires. We have 2 resistors and 3 wires. So I'm going to double click on that node to get the properties and call that one VN. I don't change the width. Double click on this node and call that node ground. So VN, ground, and then the common node's Vout. So I'll go over here, call that node Vout. But I can't see them. So I'm going to zoom in, because I have a bind key set at Z, and press Control and cycle through until I get what I want. Hit Control I. Change the size to 10. Actually, let's get that one. Let's see if I can get them all. And actually, let's change the resistors too. And then do a Control I. Oh, I deselected this. Okay, so get that one. Press Shift, not Control. That one, and do a Control I. And I want all of them to have a unit size of 10. So let me hit Apply. Looking good. And let's do an F5, a well check, and NCC, and they match. Let's make an NCC error just for the hell of it. Do Control C, Control V, fit, and then I'll press L to do an NCC. And it says there's 2 parts in the schematic and 3 parts in the layout. So I'll click on this red one because the green ones are all right. It says, hey, this one shouldn't be there. So I'll hit delete. All right, do an LVS again, F5, all those. All right, what do we have left to do here in our tutorial? Oh, we got to copy over the spice code. I don't want to retype because I'm lazy. So I'll just go here, Control C, go back over here, Control V. Yeah, but it's too small, so let's do a Control I on that while it's selected. Hit 10, hit apply just to see if that's too big. Nope, looks good. And let's see, F5, well check, LVS. Okay, we're ready to simulate. So let's go up to Tools. I have in my personal bindings, I set S up for this. So I write Spice Deck. And it's exactly the same as the schematic, which is what you'd expect. And let's pull that up. Transient signals. Let's drag this one over. Window. I can press F. And then you can see what's what, etc. And that's it. That's the end of the first tutorial. So what I'm going to do now, I'm going to save this. And then we'll pick up on this with the second tutorial. Again, remember one thing I didn't put in the written tutorial that's a good thing to include is if you go to Preferences, NCC, make sure Check Transistor Sizes is selected. All right, let's close electric and look in our electric directory and or what directory? Oh no, that's not our electric directory. Let's look in the electric directory and just see what's there. And there's my Spice raw file, there's my netlist, there's my electric log file, there's the library I just saved, there's my icon, and there's my jar file. So let's quit here.